Amazon currently deploys new code to live users every 11 seconds. If you have ever worked in tech, that number sounds terrifying. Achieving that level of velocity without constantly crashing the internet requires a total departure from traditional methods. For decades, software deployment was a manual, handcrafted process. Developers would stay up late dragging and dropping files over remote connections directly onto live servers. This relied entirely on human precision. If a single engineer made a minor typo at 2 in the morning, they could take down a multi-million-dollar platform instantly. Relying on human intervention creates a hard ceiling on a company's growth. To scale safely, a business must remove the requirement for humans to touch live production servers. Sriram Gopalan details the mental models used to solve this problem in his book, Bridge the Gap. You can find the full text at sgopalan.com/books/bridge-thegap.html. Modern engineering teams avoid manual risk through a standard known as CI/CD, short for continuous integration and continuous deployment. This system replaces manual file swapping with a 24/7 automated robot assembly line. Every piece of code must pass through a strict sequential series of checkpoints before it reaches a customer. This automated mechanism is what allows tech giants to maintain extreme deployment speed while simultaneously strengthening their safety net. This diagram shows the entire CI/CD pipeline. The process begins at the top, when a developer submits their raw code to the assembly line, rather than the live website. The first stop is Station 1, the build. Here, the raw text files are compiled into a running application. If the code contains a syntax error, the build fails instantly, the belt stops, and the mistake is caught before it ever touches a server. If the build succeeds, the application moves to Station 2, automated tests, for primary quality control. Automated robots take over, simulating thousands of user actions, like logging in or adding items to a cart, in mere seconds to ensure the software behaves correctly. Catching a functional bug here is incredibly efficient. It prevents the massive costs in engineering time and lost customer trust that occur when a bug reaches production. However, functional code is not necessarily safe code. To protect against attackers, the assembly line requires a separate security checkpoint. Further down the pipeline, we reach Station 3, Security Scan. This stage uses SAST, Static Application Security Testing. SAST acts like a laser scanner, reading the raw text for vulnerabilities or accidentally hard-coded passwords without actually running the program. If it detects a risk, the belt stops. The Heartbleed bug, a coding mistake that compromised millions of servers for 2 years, would have been caught instantly by a modern SAST checkpoint the moment it was written. Once the code passes all checks, it arrives at the final stage, Station 4, Deployment. The pipeline pushes the exact, validated version of the code, the golden image, to the live servers without any human intervention. By strictly enforcing these 4 automated checkpoints, companies eliminate the variance of human error, ensuring every release follows the same rigorous path to production. Modern software deployment functions as a rigorous, multi-step validation process. This chart highlights why simple features often take weeks. While writing the code is fast, the majority of the timeline is dedicated to navigating the automated testing and security validation needed for a safe release. Demanding rapid releases without investing in a CI/CD pipeline is a mandate to deploy bugs faster. Engineering velocity is properly measured by the ratio of successful automated deployments to broken production incidents. Understanding these mechanics allows business leaders to stop questioning timelines and start supporting the reliable infrastructure that drives growth. To learn how to translate more technical concepts into business outcomes, read Bridge the Gap by Sriram Gopalan. Scan the QR code on screen to find it. If this breakdown was helpful, subscribe to The Explainer for more episodes on how software actually works. The most successful technology companies prioritize the automated factories that deliver their code as much as the code itself.